Hello, this is Teacher Victor. This is Geography Form 2 syllabus coverage. So this lesson is going to take 1 hour 30 minutes. So after 1 hour 30 minutes I will be done with this. Then this is lesson 1, Geography Form 2. So the first topic in Form 2, when you join Form 2, the first topic you are going to be taught in geography is internal landforming processes, also called endogenetic processes. So the first one, processes operating in the interior of the earth in the formation of the natural physical features or landforms. They are caused by the earth movements. Examples of these processes are folding, faulting, volcanicity. So those are the examples of the processes. Formation of landforms by internal landforming processes is determined by internal landforming processes is determined by nature and age of the earth materials, type of movement involved, intensity and scale of movement involved. We can talk of, let's start with crustal movements. So crustal movement. So this is the displacement of the earth crust. This is the displacement of the earth's crustal rocks. They are brought about by tectonic forces which originate and operate in the interior of the earth, e.g. tensional forces which operates along horizontal plane moving away from each other. Then we have compressional forces which operates along the horizontal plane moving towards each other. Then you have shear forces which move past each other with unequal strengths. Then you have gravitational forces which attracts things to the earth's center. Kindly remember that is under crustal earth movements. Earth movements are of two types. We have horizontal, also called lateral, also called orogenic movements. We have another one is vertical, also called epirogenic movements. So let's start with the horizontal earth movements. These are movements which act along a horizontal plane within the crustal rocks. These are movements which act along horizontal plane within crustal rocks. They are caused by tensional and compressional and shear forces. What are the effects of horizontal earth movements? Number 1, they cause strain and stretching of crustal rocks due to stretching caused by the tensional forces which cause formation of cracks or faults. Number 2, they cause squeezing and shortening of crustal by compressional forces rocks which cause them also cause formation of faults, which cause them to cause formation of faults. Another effect, they cause crustal rocks to shear by slipping past each other by dividing into layers, which is caused by shear forces. That is horizontal earth movement. Those are the effects of horizontal earth movement. Results of horizontal earth movements. What are the features which come with horizontal earth movements? So the results or features of earth movements are, you have faults, rift valleys, fold mountains, escarpments, basins, tilt blocks, then we have block mountain. Remember, this question is that part is settled and they have been set in the past KCSE papers, mock papers, pre-mock papers. I am doing this so that when we start revising mock papers, KCSE papers, pre-mock papers, post-mock papers, you are having the knowledge of what is happening or the answers that I will be giving. We are going to vertical earth movements. What are vertical earth movements? These are movements which occur along the earth's radius or towards the earth's surface or towards its center. What are the effects of vertical earth movements? Number 1, sinking or pulling of crustal rocks downwards. Number 2, uplifting or uplifting or pushing of crustal rocks upwards. Number 3, tilting of crustal rocks or shear in vertical direction due to greater uplift on one side. What are the features resulting from vertical earth movements? Number 1, raised cliffs, tilt blocks, rift valleys, fault scarp, also called escarpments, plateaus, basins. What are the causes of earth movements? Causes of earth movements. Magma movement within the earth crust. Magma movement within the earth crust. We are going to gravitational force as the first one. That is B. So you have said causes of earth movements. You have magma movement within the earth crust. B, gravitational force. C, you have convectional current in the mantle. Then you have isostatic adjustment. Kindly remember that. The causes of earth movements: magma movement within the earth crust, gravitational force, convectional currents in the mantle. Then we have isostatic adjustments. So let's start with magma movement within the earth crust. When magma moves with force pushing crustal rocks horizontally or vertically, the magma moves from the surface or leaves empty spaces onto which crustal rocks are pulled downwards. Let's move to gravitational force. Gravitational force. When the attractive force of the earth pulls crustal rocks into empty spaces left after magma escaping from the surface, then convectional current within mantle. Remember, we are talking about the causes of earth movements. Convectional currents within mantle. When convectional currents in the magma in mantle drag crustal rocks by friction, horizontal movements of current cause horizontal movements of current, while vertical cause vertical movements of current, as you can see on the diagram. Isostatic adjustment. Rising of continental masses to restore the upset state of balance between shear and shimmer layers. Isostasy is the state of balance between shear and shimmer layers. If you're told to define what isostasy is, it is the state of balance between shear and shimmer layers. It can be disturbed by erosion on continents and melting of continental ice sheets. The reduced weight causes continental masses to rise. We are going to theories explaining the Earth's movement. We are going to theories explaining the Earth's movement. theories explaining the Earth's movement. What is a theory? A theory is a reason ideas intended to explain facts or ideas. There are two theories which explain the Earth's movement, namely you have continental drift theory and the plate tectonic theory. There are two theories which explain the Earth's movements. Those are, we have said, continental drift theory and plate tectonic theory. Let's start with theory of continental drift. Its proponent was Wenega. It explains the origin of 6 continents. What does it state? So what does continental drift theory state? So it states the Earth was a single cyclic landmass called Pangea, surrounded by huge ocean called Panthalassa, whose floor was a mass of seamen. Pangea broke into two parts called Laurasia, northern hemisphere, which lay around equator, and Gondwanaland, in the south hemisphere, which lay around South Pole, which was separated by a narrow ocean called Tethys, the present Mediterranean Sea. Laurasia broke into Laurasian Shield and Phenoscadia (Europe, Asia, and North America), and moved northwards to their present positions. Gondwana broke into Africa, Australia, South America, and Antarctica, and Indian subcontinent. Africa and India drifted northwards. So that is all about continental drift theory, what it states. Then what are the evidence supporting the theory? What are the evidence supporting continental drift theory? Number 1, fitting of western coast of Africa and South America into a jigsaw. Number 2, discovery of coal 40 degrees north and 55 degrees north, which was formed by burying a tropical vegetation. Number 3, considerable displacement of rocks along some faults, e.g. along the Great Glen Fault of Scotland. Number 4, Cape and Buenos Aires faults resembles one another by having east-west trend. Red Sea. Number 5, Red Sea show evidences of having undergone lateral displacement, an indication that it was formed by movement of the Earth's crust. The 6th evidence, and the very last one, evidence of ancient glaciation to the south of equator in Africa, in Madagascar, and India, where there is presence of ancient glacial deposits suggesting these areas were once around South Pole. Those are the evidence of continental drift theory. You must know them as a student since they will be in your exams. Number 2, we are going to plate tectonic theory. What does it state? The Earth's crust is made up of blocks called plates. What are these plates? We have Eurasian plates, Australian plates, African plates, Antarctic plates, we have North American plate, South American plate, then we have Pacific plate. Smaller ones, those are the 7 larger ones. Then the smaller ones, you have Indian, Arabian, Caribbean, Cocos, you have Somali plates, Juandivuca plates, Nazca plates, Philippine plates, and Scotia plates. These plates are 2 types. We have these plates are divided on 2 types. You have tectonic plates. So these tectonic plates are divided on 2 types. So you have oceanic plates, which form major areas of the ocean floor, including coastal lowland. Then we have continental plates, which form the bulk of continental land mass. The plates float on a molten mantle layer called asthenosphere. The plates float on a molten mantle layer called asthenosphere. From lesson, we have a lesson in Form 1 notes where we said what is asthenosphere. The plates move relatively to each other due to convectional currents in the mantle. They move away from each other, forming extension or constructive boundary called so because magma fills the space between. They move towards each other, forming compressional or destructive boundary called so because materials between them are crushed. The movement of those 2 types of plates have the following effects. What are the effects of movement of plates? Number 1, when 2 oceanic plates meet, what is happening? When 2 oceanic plates meet, there is subduction and the ocean floor is pulled inwards, forming a trench. E.g., you have Java Trench. A subduction is the process of edge of one plate beneath the edge of another. What is a subduction? Is the passing of edge of one plate within the edge of another. We have sediments. Sediments on the sea floor in the region of a subduction are compressed to form fold mountains. When an oceanic plate meets a continental plate, the edge of the oceanic plate slides beneath the continental plate in a movement called subduction. Sediments on the sea floor in the region of subduction are compressed to form fold mountains. Fold mountains are also formed at the edge of a continent, at the edge of the continent when the shear layer is compressed. The edge of the oceanic plate bends into the mantle, forming a trench. Number 2. When 2 continental plates collide, the shear layer is folded into mountain. They move past each other, forming transform and conservative boundary, called so because there is neither construction nor destruction which occurs when the plates are separated by a major fault. Significance of plate movements. What are the importance or significance of plate movements? Are source of earthquakes and volcanicity. They are source of earthquakes and volcanicity. Causes formation of landforms such as fold mountains and ocean trenches. Spectacular landscapes formed are tourist attraction. The eruption of magma can result in the formation of valuable materials. Those are the effects or significance of plate movements. Let's move to folding. What is folding? Is the process in which a crustal rocks are distorted by compressional forces by being caused to bend upwards and downwards. If you're told to define folding, you say it is the process in which the crustal rocks are distorted by compressional forces by being caused to bend upwards and downwards. It occurs on a fairly young sedimentary rocks. It occurs on a fairly young sedimentary rocks. Kindly take a look at the diagram as it is set in exam. You'll be told to label the parts or draw and label, or they will give you a diagram like this, then they will tell you to name. So we have crest, anticline, syncline, trough, axis and limb. Kindly check a look on the diagram. It is very important. Anticlines. What are anticlines? Part of the Earth's surface which bend upwards when folding occurs. Synclines. Parts of the Earth's surface which bend downwards when folding occurs. Crest. Uppermost part of anticline. Uppermost part of anticline is called crest. Trough. The lowest part of syncline. The lowest part of syncline is called trough. Then you have limb. Rock layers sloping on both sides of the fold. Rock layers sloping on both sides of the fold. Axis. Imaginary line drawn vertically through the center of the anticline. Kindly take note of the diagram. It is very important. It is always settable. Types of folds. What are the types of folds? We have number one. We have simple symmetrical folds. Take a look of it. It is settable. Simple symmetrical folds. Which are what? So we are still explaining that. Which are symmetrical about the anticline, formed by two compressional forces of equal magnitudes. So simple symmetrical folds are formed by two compressional forces of equal magnitudes. Number two, asymmetrical folds. What are asymmetrical folds? So asymmetrical folds, the anticline axis or in which one of the length is steeper than the other. So you can have a look at it, formed by two compressional forces of unequal magnitudes in which one is stronger than the other. So asymmetrical folds are formed by two compressional forces of unequal magnitude in which one is stronger than the other. So you can have a diagram. Then you have overfolds. So this is one overfolds. So in which anticline of the fold is pushed over the limb of the other. So you can see that anticline of one fold is pushed over the limb of the other. We have isoclinical folds, which are packed closely together and with the limbs almost parallel to each other. A vertical isoclinical folds are formed by compression forces of equal magnitude, while inclined isoclinical folds are formed by forces of unequal magnitude. Kindly get to understand what we are talking about. Then we are going to recumbent folds. Lie on horizontal manner, formed by two compressional forces, one of which is strong. The next one is nape or overthrust fold. One limb is pushed over the other. The forces are very strong and they cause a fracture or fault to develop. Then we have anticlinorium or synclinorium complex faults. Faults characterized by minor upfolds and minor downfolds. Land is first subjected to weak compressional forces resulting into minor folds. Later, the land is subjected to much greater compressional forces resulting into new upfolds which minor folds and new downfolds with minor folds that. So what are the results? What are the features that results due to folding? What are the features that results due to folding? Resultant features due to folding. Number 1, fold mountains and their distribution. So we're going to talk about fold mountains and their distribution as one of the features that result due to folding. World's highest and most impressive mountains and the most conspicuous features of folding are, we have Himalayas in Asia, Everest, Nepal, Tibet border, highest point. Then you have Andes, Peru in South America. Then you have Alps, South Central Europe. You have Rockies, West Northern America. Then you have Atlas, Northwest Africa. Then you have Appalachian, East Northern America. Kindly remember this, as it is also set in exam. You will be given Himalayas, then you state a place where it is found. So we have talked about Himalayas, Asia, Andes. It is in Peru in South Africa. Alps is South Central Europe. Then you have Rockies, Western North of America. Then Atlas is Northwest Africa. Then you have Appalachian, you have East Northern America. Theories of origin of fold mountains. We have theories. What are the theories of the origin of fold mountains? Number 1, we are going to talk about contraction theory. Theories that explain the formation of fold mountains or the origins of fold mountains. Number 1, we have contraction theory. During the Earth's formation, surface rocks cooled faster and recooled to form a fold mountain. That is what that theory says. During the Earth's formation, surface rocks cooled faster and recooled to form fold mountains. Number 2, we have convectional current theory. Horizontal convectional current in the mantle exerted frictional pull on the crustal rocks. Continental crusts were pulled towards each other. Sediments between them were squeezed into folds. So that is what convectional current theory says or states in the formation of the fold mountains. Number 3 is continental drift theory. Continental drift theory says during the break of Gondwana land, India drifted northwards and collided with Eurasia. Sediments between were squeezed to form fold mountains, e.g. Himalayas and Everest. Then you have plate tectonic theory. It states when an oceanic plate meets another or it melts a continental plate, the sediments under the sea are compressed to form fold mountains. The two continental plates meet, the shell layer is compressed to form fold mountains. E.g., we have Alps was formed when Africa plate pushed against the rigid European plate. Let's go to escarpments as another feature which is formed due to fold mountain. Escarpments. What is escarpment? From the diagram, as you can see, it is a relatively continuous line of steep slopes facing the same direction, formed one compressional force causes folding, resulting in one steep length of the anticline, which forms the escarpment. The third feature which is formed is depression, formed when not very strong forces causes folding, causing some parts of the Earth's surface to form synclines, forming basins. Number 4 is ridges and valleys. These are features formed by folding, ridges and valleys. When folding occurs, anticlines form upwards or ridges, while synclines form valleys. Rocking plains which appear to rise and roll, formed when plains are acted upon by weak compressional forces, resulting into gently sloping anticlines and very wide synclines. We have intermontane plateaus, a highly level land between mountains, formed when rocks at the edges of a region become intensely folded and the middle part resists folding, resulting into mountains which enclose a highly level land. Remember, we are still talking about the features that are formed due to folding. Intermontane basins formed when some parts of the intermontane plateau sink more to form basins. What are the significance of folding? To human activities or economic activities? It can either be positive, which are advantages. So we are going to divide it into positive. So we are going to start with positive significance of folding to human activities. The first one, fold mountains are tourist attraction which brings foreign exchange. Number 2, fold mountains are water catchment areas and sources of rivers. 3, some fold mountains have valuable minerals deposits such as coal and petroleum. 4, fold mountains act as protective barriers during war. 5, some fold mountains on the path of bearing rainfall influence rainfall, causing the windward slopes to receive heavier rainfall. Number 6, folding can lead to formation of valuable minerals due to metamorphism. Folding can lead to formation of valuable minerals due to metamorphism. 7, folding brings valuable minerals to the surface, making them easily available. Negative effects of folding, or what are the disadvantages of folding? The first one, fold mountains on the path of rain winds cause the leeward slopes to receive less rainfall. Fold mountains on the path of rain winds cause the leeward slopes to receive less rainfall. Fold mountains discourage settlements due to cold temperatures and ridged terrain. Folding can lead to burying of minerals. Folding mountains are a barrier to road and railway where there are no passes, and there are passes, they may be covered by snow. Orographic fog hinders pilot visibility. What are the significance and importance to the physical environment. What are some of the importance of folding to physical environment? Number one, folding can result in submerged coastal zones which are used as harbors. Number two, can lead to metamorphism of rocks, changing their original state and making them more resistant to erosion. Number three, depressions formed by folding turn into wetland, important for water purification. Number four, folding leads to faulting and magma. Folding leads to faulting and magma may escape through faults, leading to volcanicity and earthquakes. Let's move to faulting. What is faulting? Faulting is the cracking and fracturing of the brittle crustal rocks due to tectonic forces. Faults are fractures or cracks that develop in the crust. When tensional forces cause crustal rocks to stretch and fracture at the region of maximum tension. When compressional causes squeezing of crustal rocks to fracture at the areas where they are intensely squeezed. When vertical movements exert pressure on rocks, leading to fracturing. When shear forces cause crustal rocks to shear. So those are how faults develop. I've given you how faults are developed in the crust. We have talked about when tensional forces cause crustal rocks to stretch and fracture at the region of maximum tension. We have also talked about compressional forces. When compressional forces cause squeezing of crustal rocks to fracture at the areas where they are intensely squeezed. We have also talked of vertical movements that exert pressure on crustal rocks leading to fracturing. We have talked of shearing forces causing crustal rocks to tear. Check at the diagram. Very important, you will be told to name the parts, or they can give you a diagram of this particular picture or figure you can see, then they will tell you to name. Kindly take a note, draw and know the parts. It is very important. Parts of a fold, very important. Upthrow. What is upthrow? Part of the land displaced upwards. Upthrow, as you can see on the diagram, it is part of the land displaced upwards. Number two, downthrow. Downthrow is part of the land displaced downwards. Then you have throw. Throw, vertical displacement. Eve. What is eve? Eve, horizontal displacement. Ed is the inclination of a fault to the vertical plane. Fault line. Fault line. What is fault line? A fault path. Then you have fault plane. What is a fault plane? As you can see on the diagram, separation of land created by the fault. So we are going to talk about the types of faults. What are the types of faults? So types of faults, very common question. You'll be told in exam to name and explain the types of faults, or you can just be told in section A just to name the type of faults. Number one, normal faults. What are these normal faults? This type is formed by tensional forces in which one block slides downwards in relation to the other. In relation to the other, rocks are subjected to tensional forces. Rocks are subjected to tensional forces. As you can see on the diagram, a normal fault develops. A normal faults develop. One block slides downward. One block slides downwards. Then that is how normal fault is formed. Number 2 is reverse fault, formed by compressional forces in which one block of the land is pushed upwards in relation to the other. Rocks are subjected to compressional forces accompanied by the diagram. As you can see, compressional forces. A reverse fault developed. A reverse fault developed. One block is pushed over the other. One block is pushed over the other. That is it. The next one is shear or tear fault. Shear or tear fault, formed by shear forces in which adjacent blocks of the land slide past one another. If a shear fault occurs between the continents, it is called transform fault. E.g., we have San Andreas fault of California and Great Glen fault of Scotland. Let's talk about thrust fault, formed when very strong compressional forces cause almost horizontal faults to develop and one block of land is pushed over the other. Let's talk about anticlinical fault, formed when anticlines are compressed further and cracks form on the crest. That is how anticlinical faults are formed. What are the features resulting from faulting? What are the features resulting from faulting? With the first one, we have escarpment or scarp. Escarpment or scarp. We explained that it is a steep line of slopes formed by vertical movement of earth along a fault. E.g., we have Mau, we have Nguruman, we have Nyandarua, and we have Nandi. Are exposed parts of a fault plane. Escarpments are exposed parts of a fault plane. It may be formed due to normal faulting, reverse faulting, when overhanging blocks are eroded. Number 2 is fault steps. Fault steps. It is a land resembling the staircase or steps of a house, which with a series of fault scarps at different levels. A parallel vertical faults develop. Land between the fault is unequally displaced downwards. A series of fault scarps at different levels is formed. Example of that, you have Keio escarpment and at Kijabe. Fault blocks, also called block or host mountain, as a feature which is formed due to faulting. Blocks of land raised above the surrounding land. When tectonic forces cause faulting, a land on one side of the fault get raised or sink the fault planes. Example of fault blocks, we have Aberdare or Nyandarua ranges, we have Mau escarpments and Nandi Hills. When blocks of land bordered by normal faults, which are almost parallel to each other, sink, leaving the middle block standing. Example of hosts we have Zuwenzori of West Uganda and Usambara and Pare mountains of Tanzania. You have tilt blocks. Fault blocks. Remember, we are still talking about the features resulting from faulting. We have tilt blocks. Fault blocks which are inclined on one side. occurs when the fault block, host, or fault steps have a greater uplift on one side, and as a result, they are not flat at the top but tilted. The resultant feature are tilted fault blocks, tilted hosts, and tilt fault steps, which form ridges and fault-guided valleys. As you can see, everything is accompanied by a diagram. You have Rift Valley as another feature. Rift Valley along narrow trough with steep escarpments on both sides. Theories of formation of fault blocks. What are the theories of formation of fault mountain? So we have tensional theory. Rocks are subjected to tensional forces. Normal faults, which are almost parallel, develop. One block slides downwards, forming the Rift Valley. Then that is all about tensional theory on the formation of faulting. We have compression theory. Rocks are subjected to compressional forces. Reverse faults, which are almost parallel to each other, develop. Reverse faults, which are almost parallel, develop. The side blocks are pushed over the middle. Then overhanging blocks are worn out by denudation to form escarpments. Overhanging blocks are worn out by denudation to form escarpments. Then we have anticlinal theory. Suggests that Rift Valley was formed by anticlinal arcing, where upward forces pushed a sedimentary rock strata upward. The rock layer bent into a big arc. A gaping or a huge crack developed at the crest of the arc due to tension, forming the Rift Valley. So let's talk about the Great Rift Valley. The Great Rift Valley. It is the world's biggest rift valley. It starts in Syria and ends in Mozambique. It is divided into 4 parts. So the Great Rift Valley is divided into 4 parts. Number 1, Ethiopian Rift System. Starts from afar in Africa, in Ethiopia, to the Kenyan border around Lake Stephanie. Gregory Rift System. Gregory Rift System starts from the northern border of Kenya with Ethiopia to Tanzania. It has a small northeast and southwest branches. Kano Rift Valley in Kenya, and Lake Eyasi Rift Valley in Tanzania. Number 4, Western Rift Valley. Starts at Sudan border to south of Lake Rukwa. Features which are here are Zuweri Mountain and Lakes Albert. Lakes you have Albert, Edward, Kivu, Tanganyika, and Rukwa. Number 4 part of the Great Rift Valley, the last one, is Malawi Rift Valley. Is a continuation of a Gregory Rift Valley to Zambezi River in Mozambique. It has a small northeast and southwest branch called Lungwa Valley. The Gregory Rift Valley, it is named after a geologist called Gregory, who carried out extensive studies in this area. It is where the Rift Valley features are more pronounced. What are the features? What are some of the features of Great Rift Valley? Number 1, fault blocks. You have Aberdare Range, Mau, Nandi, and Cherangani Hills. Next, number 2, you have step faults. You have Kijabe and Tambach. Then you have a tilt blocks. You have Aberdare Range uplifted and tilted to eastwards, and Mau escarpments uplifted and tilted westwards. We have lava flows. Number 4, lava flows and volcanic cones. Those are, you have Menengai and Gorogoro crater. Rift Valley. The last one, number 5, the Rift Valley lakes formed when unequal sinking created faults which were later filled with water. The lakes are deep and elongated. Examples of these lakes, we have Lake Naivasha, Nakuru, Element Taita, Baringo, Bogoria, Bosolat, and Turkana. Most of the lakes are salty with the exemption of Lake Naivasha, which is a freshwater body. Why most of the Rift Valley lakes are salty? Why are most of the Rift Valley lakes are salty? A question which is being set every time. Why most of the Rift Valley lakes are salty? Number 1, lack of outlets to drain away salts contained in them. Number 2, lack of enough water to dilute salinity due to little rainfall and lack of rivers flowing into them. Number 3, high rates of evaporation causing increasing accumulation of salts. Number 4, lakes water being in contact with the rocks with minerals salts which it directly dissolves. Lake water being in contact with the rocks and the mineral salts which it directly dissolves. So the presence of a rock lying on the ground makes those lakes salty. The last one, number 5, washing into the lake of minerals rich soils by surface runoff. Washing into the lake of minerals rich soils by surface runoff. Why Lake Naivasha has a fresh water? Why does Lake Naivasha has a fresh water? Why Lake Naivasha has a fresh water? So the first one, it has underground drainage to the Indian Ocean. It has underground drainage to the Indian Ocean. Number 2, there is inflows of fresh water from rivers and rain. There is inflow of fresh water from rivers and rain. The last one, the latest volcanic eruption covered the bedrock with lava. The latest volcanic eruption that occurred covered the bedrock with lava. Those are the reasons why Lake Naivasha has a fresh water. So if you are told in exams, and I am very sure you will be told in exams, give reasons why Lake Naivasha has a fresh water. So we have major faulted areas of the world. What are the major faulted areas of the world? Number 1, the Great Rift Valley from Syria to Mozambique. Number 2, Northern England and the Great Glen Fault of Scotland. Number 3, the Central Massif of Europe. Then you have the Middle Rhine Rift Valley region. We are going to talk about the significance of faulting. What are the significance of faulting to human activity as the first one? So let's talk about what are the significance of faulting to human activities. Number 1, Rift Valley lakes are important for fishing, irrigation, and domestic use. Number 2, the Rift Valley has some features that are tourist attraction which earns foreign exchange to our country. Number 3, hot springs and geysers formed during faulting can be harnessed for geothermal power. So hot springs and geysers can be used for geothermal power. Fault block mountains. Block mountains are water catchment areas and sources of rivers due to the heavy rainfall they receive on the windward side. So block mountains are water catchment areas and sources of rivers due to the heavy rainfall they receive on the windward side. Number 5. Faulting results in the exposure of minerals such as diatomite in Gilgil, then we have fluorspar in Kerio Valley. So faulting results in the exposure of minerals such as diatomite in Gilgil and fluorspar in Kerio Valley. Number 6. Fault scarps may expose underground water, resulting in the formation of a scarp springs. Fault scarp may result to formation of scarp springs. Number 7. Unequal subsidence caused by faulting may cause formation of depression, which may form lakes, which is useful for fishing, transport, and mining, e.g. we have Lake Naivasha. Those were the positive effects of faulting. So let's look at the negative effects. What are the negative effects of faulting? Number 1. Faulting disrupts transport and communication. Faulting disrupts transport and communication by disjoining them or disjoining land. Number 2. Faulting may lead to loss of life and property by causing land to slide. Faulting may lead to loss of life and property by causing land to slide. Number 3. Faulting may cause a river to disappear or change its course and flow along the fault line. Faulting may cause a river to disappear or change its course and flow along the fault line. Number 4. Steep scarp slopes formed by faulting are prone to soil. Steep scarp slopes formed by faulting are prone to soil erosion. Number 5. Faulting has given rise to semi-desert conditions in some areas when block mountains on the path of rain winds cause leeward sides to receive little rainfall. Let's talk about volcanicity. So as I said, I will always do 1 hour video. We are going to proceed from this in our lesson 2, where we are going to talk about volcanicity. So have a nice time. Kindly feel free to comment, share, and subscribe for the latest teachings and lessons that will be posted by Teacher Victor. This is Victor Online Learning Platform, Victor Online Learning Platform, where I will be teaching you and also helping you to cover syllabus, whether you are adult schooling, homeschooling, or revising for your examination. Alongside, I will be doing KCSE revision, pre-mock, mock, post-mock examinations. Kindly feel free to subscribe to this channel. Let's meet in the next class of volcanicity. Thank you.